Hello everyone. My name is Bharath Reddy Baddam. I have around 9 years of experience in Salesforce, cloud technologies, and AI-driven solutions. I have worked with finance, healthcare, and real estate industries. Today, we are going to talk about a problem that resonates across industries. Why so many promising machine learning models never make it into production? And how MLOps practices can help bridge that gap. Think of this talk as a roadmap. From research to production, ready systems covering the challenges, orchestration, infra, monitoring, and CI/CD for ML. Today's agenda. Our journey will move across 5 pillars. The MLOps challenge. Why so many models get stuck in the lab. ML pipeline orchestration, tools and techniques to automate workflows. Production infrastructure, how to make ML systems scalable and reliable. Monitoring and observability, ensuring model continues to deliver value after deployment. CI/CD for ML, adopting DevOps best practices to machine learning. By the end of this session, you will have a complete picture of what MLOps maturity looks like and how organizations can achieve. The main challenge, the MLOps challenge, let's start with the problem. Studies show that 20% of ML model servers ever make it to production. That means 4 out of 5 projects never deliver value beyond research. Why does this happen? Some key barriers include reproducibility gaps between research and engineering, lack of standardized deployment process, insufficient monitoring and maintenance of framework, and inadequate testing methodologies for particularly ML systems, poor integration with enterprise systems. I am sure you have seen brilliant proof of concepts die in a lab because of these exact issues. The MLOps evaluation. Over the years, MLOps has matured in stages. Manual ML process, isolated notebooks, one-off deployments, and no repeatability. And we have ML pipeline automation, basic training automation, but limited to production integration. CI/CD for ML, bringing DevOps rigor, automated testing, structured releases, and inconsistent deployment. Full MLOps maturity end-to-end automation, monitoring, drift detection, retraining, rollback strategies. For organizations that reach maturity, reduce deployment times by 80% and it will sustain 95% accuracy in the production environments. This is not a just technical just transformation. It's a cultural work. These engineers and operation teams collaborate seamlessly. ML pipeline orchestration. Now let's dive into orchestration. Imagine the ML lifecycle as a factory assembly. If any step is manual or fragile, the whole process slows down. A fully automated MI pipeline should cover data prep, cleaning, future engineering validation, and model training in that hypermarket tuning tracking experiments. Model evaluation, testing against holdout datasets, and validating business KPIs. Deployment, packaging, and serving models consistently. And the other one is monitoring. Continuous watch for drift, errors, and performance issues. Without this orchestration, every new model is a reinvention of the wheel. And MI pipeline orchestration components. Different teams choose different orchestration tools based on their ecosystem. For example, for Kubeflow. Kubeflow is the one thing. It has a Kubernetes native platform. Great if our org is already invested in Kubernetes, it has strong model serving and pipeline libraries. MLflow, it is lightweight, experiment tracking, model registry, and language specific. Perfect for the experimentation and for that particular heavy teams. And Airflow, Apache Airflow, a general workflow engine. It is not specific to ML specific, but great for complex data heavy process. In practice, many organizations have mix and match of these comparison tools. So for example, you might use MLflow for experiment tracking. While deploying models, we have a QB flow. When picking tools, always ask, does this fit our workflow or skill set? Or are we forcing the team unnecessary complexity? Production infrastructure. Even the best model failed without the right infrastructure. Here, what modern ML infrastructure looks like. Infrastructure as code with Terraform or Pulumi, ensuring environments are reproducible. Containerization with Docker. Packaging dependencies to eliminate it works on machine. Deployment automation like CI/CD pipelines pushing code and model across dev, desk, prod. Scalability, Kubernetes auto scaling for spikes in production. Cost optimization, dynamic scaling, and right size. The main goal is to build infrastructure that is as real as the model themselves. Yeah, real time inference architecture. Many applicants, many applications, fraud detection, chatbots, recommendation engines require real time predictions. That means 50 to 20 millisecond latency. Key design considerations. Horizontal scaling. Kubernetes clusters that scale out with the demand. Load balancing. Ensuring requests spread evenly with health checks. Caching. Using Reddy's for frequent queries. It will reduce the compute. Hardware acceleration, kind of GPUs and DPUs wherever needed. One example at a healthcare client, real-time insurance eligibility checks, they reduced wait times from minutes to milliseconds because they model on an optimized auto-scaling architecture and real-time inference architectures. For example, horizontal scaling, load balancing, caching layers, hardware acceleration. These are the things. Monitoring observability. Deploying a model is not the beginning. Model drift has changes. Monitoring covers three layers: data drift, statistical checks, KI divergence, and population stability index. For model performance, says accuracy, F1, AUC, and we have to continuously track against those benchmarks. Operational metrics, latency, throughput, as well as resource utilization is the main. If you are not monitoring, you are playing behind. And that's dangerous in production. We have to maintain that properly. Model monitoring systems, automated retraining deployments. How do we respond for that? How do we respond if drift is detected? Automated retraining. Common triggers. Performance drops below threshold. Time-based schedules, weekly or monthly retaining. Database triggers, significant distribution shift. And we have to follow the distribution and deployment strategies, shadow deployments. New models will run silently in parallel. Canary releases roll out for percent of the traffic before scaling down. And A/B testing, measuring the business impact. We have to test it thoroughly. And automated rollback if the new model underperforms. If it is not performing perfectly, we have to roll back that functionality. And we need the deployment strategies to be in place. These combinations ensures both agility and safety particularly. Thank you. And particularly automated retraining, we spoke right, performance-based, time-based, data-based, value-based. Those are the main key things. And CACD for machine learning. Finally, we have to speak about CACD for ML. DevOps transforms software engineering, MLOps does the same for ML. Key test in ML CI/CD pipelines, data validation, schema checks, missing value detection, model, model performance tests, regression checks, prevent black sliding, integration test. We have to validate the entire pipeline and load and performance test, ensuring the production readiness based on the application, security and compliance test. We have to follow GDPR, PA production. We have to, security is the main concern. Without these all models, whatever, these will, if these are not there, that particular models will be failed in production. With them, ML becomes predictable, repeatable, and it is there. And in ML specific strategy for testing, we have different data validation tests, model performance test, integration test, load and performance test. We have to verify the data for data validation, and we have to check we have to validate every scenario. Model performance test, we have to check whether we met the model or not. If not, we have to check that particular. And the integration test validate the entire pipeline. And load performance test ensuring the production, the readiness, security compliance, and everything. And coming to the real challenge of this is most of the ML models never have the never reach the production. MLOps offers a way forward from orchestration to infrastructure, monitoring, and CAC. It means that process is not just about the models, but about the system, culture, and collaboration. If there is no one takeaway, treat machine learning as a product, not a project. Product requires lifecycle management, testing, monitoring, and continuous improvement. These are the key things for us. Thank you for your time. If you have any questions, please reach out. Thank you very much.